Hello everybody, again, I'm Esteban Lorenzano and I'm here since the first day doing talks one and another again, and this time is the last one. For everybody is going to be pleased for that and me the first on it. So I'm going to talk about Pharo CIG. Pharo CIG means Pharo C Interface Generator, but this is the round 2, Beyond the Bridge, because 2 years ago I presented this project in a talk that was talked Bridging the Gap. And the thing was about to generate C interfaces for being used in Pharo. So, because the problem is more than just having an FFI, because today in Pharo, FFI is not an obstacle. We already have a very good and very mature FFI implementation. For those who do not know, FFI means Foreign Function Interface, because sometimes that means the capability of connect to other libraries than the ones that are made in Pharo. And we already have that. We have portable calls. That means that you can call C libraries that are in Windows, Mac, or Linux, or whatever, provided that it has libFFI. It has a libFFI, which is what we use as a backend. We have callbacks, which was something that was missing from a lot of years in Pharo. We have callbacks since a lot. We have thread support. We can fork a thread and use that to call a library, which means that our image is not stuck there. And it's very mature, and it has been evolving with the years. Even this year, Unified FFI incorporates different details that I'm not going to talk about, but that makes the programmation, the conversion between C and Pharo a lot easier. The conversion, but that was not the bottleneck, because the real problem with this is that when you do a project for real, Pharo and Smalltalk in general is a small community, and it doesn't have all the libraries that you need, and then you need to use an external library, and that external library means sometimes hundreds of functions, enums, types, comments, everything that needs to be translated. And before, what I did, you needed to do it by hand. And in fact, all the spec.gtk backend that you see in use in my previous presentations, are made by hand, for example. And that's hundreds of functions and a lot of work. And so, one library is often a small software problem. So you have to copy the headers in the class, you have to debug to see that everything is fine, and then you have to maintain it. So when you have a real project, and everybody has real projects and have to do the same work one and again by hand, this is not enough. An FFI is not enough. So CIG, what does CIG is what a computer does. It turns something into information that allows you to create a repeatable process. Like a compiler takes a source and generates a program that you can execute. If a computer can do that, we should be able to make sense of a C header the same way as a compiler and take that information for us. So what we do is exactly that. We use libclang to parse the header and generate a library and generate a low-level binding stuff from a description that you do, a specification that I call receipt, because since half of my projects already are named spec, I I decided to call that recipe just to make a difference. But it's that, it's a specification of the library, and it's not my magic. The advantage of this is it's a repeatable process. This is the recipe is the important artifact that we produce. This is very simple. We are going to see in detail now, and it records what we are going to import, where headers are living, all the name and decision, the required configuration, and how generate it again. The idea is to be able to put this in a CI and generate the new versions of the library in an automated way with that. But of course, let's check this a little bit. This will produce an interesting library that I'm going to show more in detail like that. This is visible, no? Yeah. This is libqrencode. Libqrencode is a standard standard in Linux for generating QR codes. It's the smallest library that I could find for an example. And it was so cool that after that I started to put QR codes in all my presentations, so that's why you see them all around, because I did it. So you map it this, and the first thing that you have is that the mapping is completely autonomous. It will not create any dependency with anything else other than what it is already in the image. This is different to other approaches. You see the baseline that does not have dependency, but also the package. If you see the package, here you have all the package that is generated, and you see, but it has a dependency of Alexandria because I create an example. The example generates a surface and as Alexandria, but that's the thing. Otherwise, it doesn't have any other dependency. This is important because then you don't need to bring undesirable things to your program. You just import what you want and you use it. And in the same way, you will have, for each opaque object that you have, it will generate a base object and all the descriptions. This is just a plain opaque object. An opaque object is something, it's a structure that you don't know the contents, so you use it as a pointer in C. And all the numerations, this is very, very small, so it generates perfectly the things. And the structures the same. You will check, it will generate some, let's see, a field desk. It will check. It is still readable, no? I'm sorry. I cannot change the resolution because I'm going to lose the monitor because it's complicated. And we want to finish this soon, so Nori, which already has the last talk before lunch, can finish soon and we can all go to it. So, okay, but this, so it will generate the information correctly. The other thing that is interesting is that it generates not just all the functions. Here you see this is the recipe convention, and it will generate all the functions more or less in a good way. One thing that is interesting is if the header is well built, it will try to get a lot of information that you can use later. For example, the comments of the functions, the comments of the structures, and that, and it puts it correctly there. So finally, what it does also is to extract the constants. All the macros that are there, here is not much, it's just 2. We will see something later. It tries to extract it and generate it and give it to you in a share pool so you can use it. In this case, it's not needed because it's just a version, but maybe you can need it for checking something. But okay, but it's not very needed. But there are other things that are more needed. So, and that's more or less how it looks. But this is a very easy recipe. as you can see. This one is a little bit more complicated. That's OpenSSL. That was my biggest achievement with this library, and it's very, very complicated. As you can see here, you can even define your own header. It's like you are doing a program in C, you define, I'm going to use all this, I give it this header. And since I didn't want to bring other libraries, I just redefined some struct time, because otherwise you have to bring timet.h and start. So I just redefined that, and then I included all the things because I want everything there. And I think I needed to make some type defs that this is going to be an opaque object, because that's why it's going there, because I do not need the details of that. Some synonyms and blah blah blah. An important thing that you cannot read it, which is a constant generator that says that it's going to have some characteristics. Because what changed in these 2 years, I didn't move a lot other than make it mature. But what changed in these 2 years is that I added a lot of advanced customization. You can transform your elements because, for example, sometimes you ask for a function and it gives you a string, which is a char pointer. And the char pointer, depending on the library, this is going to, you need to dispose that, you need to do free or not. But if you declare it as char pointer, Pharo will answer you a string. And the string, how you dispose a string? So there you will have a leak. So you have to say, okay, give me instead of the string, give me a pointer so I can handle, I can then read the string and dispose it manually. A lot of different small things, small tweaks that you need to do to correctly parse, read the library. Name tweaking, was my comment with Martin yesterday. You can do a lot of things like strip, modify names, create the things as you want. Even if I disagree with Martin this, he wants to be closer to Smalltalk. I think that if you are going to work with C anyway, it's better to be as close to the library that you are using as you can, because that will put you closer to the documentation, that will put you closer to work with the library as the library expects you to use it, which is something that we learn between Cairo and Alexandria. For example, is that using libcairo is not straightforward. You need to use it as they want you to use it, if you want the speed. If you're just doing your stuff and you create the things as your super nice object model will tell you, it will be slow. And that's in fact why we create Alexandria, because it was not being fast enough. And then constant generation, this is very nice because I just presented something that just have just 2 constants. But for example, OpenSSL has a lot of constants. Let me check. And if you see here, you will see all that are classes, the classes of the constants generated. For each here, I have different strategies of grouping, because for example, first I was trying to put everything in just one share pool, but at the moment I ran out of space and it was breaking everywhere. That was not possible. So I have different, I can group by initials, and you give up by prefix, or by prefix, by alphabetical in A, B, C, or like this by header. And then you have one that concentrates everything, so you just have to import one, and you have access to all the to all the variables, but you have that. And so how that works, in fact, you have to generate a program and execute it, because it's the only way to extract from C a real value of a macro is to have a program. So I have a program that prints the value of everything, and I execute it for everything, and sometimes it's fail. I cannot parse all the time. And then the other thing that is missing and I wanted maybe to discuss with you also, is the macro generation, because there are macros that are used as functions. So what we do with that? I just create a companion library that will generate that as functions, so I can access it, because I cannot access that from Pharo. But that's still pending. And the idea is that everybody can do their own and contribute it, so we can generate an ecosystem of different of naming generator, for example, because you can have different Williams, like Martin that wants to be close and I want to be the other side, whatever. Okay, so the generation will give us the low level layer quickly. It will generate a lot of things, but then this is maybe not the best solution, but since it will never remove anything that you do, so that you generate. So if you start to build on top your own abstractions, because you have C as low level, but then you want to actually be a small talker and do stuff, you want to generate this, you can use it to build on top. For example, to add functions inside an opaque library, like then you have an opaque object on that. So you have an object-ish way of behaving instead of a plain C. So, but this is a start, and it already gives you something you can use it. And this is now usable. It's not complete. We will see later, and it's not absent of frictions, but it's useful. Useful enough to start disappearing as something very visible and be part of the ecosystem in real work. I say once that a framework becomes so used, you forget that it's even a framework. That's the thing. So it's already being used as infrastructure. One thing that I have to say is that one decision I made is, and that's because of Sabine was still working in Pharo 11 and she has a problem in Pharo 11 and I needed to work it. So, but then I say, if we use the same VM from Pharo 11 to here, why we cannot use the same? Why we cannot reuse the Pharo bindings that we do, the C bindings? Because what could change that forbids that is the FFI implementation, the backend, the VM part of the things. But if that doesn't change, why we cannot use it? So we are backward compatible until Pharo 11 today with everything, except that what you need to load unified FFI. I make sure unified FFI is extracted from the image in a way that is, you will always have what is in the latest image there, and in a way that I ensure that is backward compatible. You can load it because it's still provided that you can, in a way that you can load in Pharo 11, from Pharo 11, Pharo 12, Pharo 12. So you will need to work in that because unified FFI, the Pharo package, change. But you load that, and you will be running with any library until Pharo 11. I use extensively for Pulsar, but also the coming Pharo SDL3 implementation is based on this. So I think it's start to be really useful. But then but the problem is not that. The problem is that private bindings, the ones that I do for my projects, or even if it's Pharo is for SDL3, is the one that do not make an ecosystem. And what I want here is to stress the importance of create this ecosystem, because every project, if every project has its own wrapper, that's something that the community loses and people loses as a possibility to work, and they have to do their own bindings again for probably the same problems, the same kind of problems. So the idea is that I created now a common place where people can contribute, and that's the Pharo interface garden. In fact, it was C interface garden, but I made a mistake when I was typing, and okay, Pharo interface garden works fast. And it's just a group in GitHub where you can put different stuff. Garden is more than a package catalog, but it will be a package catalog. It's a place where you can put recipes, headers, build nodes, platform. Then you can put your generated libraries, and you can put whatever you want to recommend, paths, whatever to do that. So growing a garden of C libraries. What can live? Everything. So everything you want and even more, and I'm going to speed up a little bit because I'm running out of time. But the idea is to have a place where you can put everything, and it's a place where people can find the things and contribute the things, just to avoid repetition of work. And contribution should be a normal path. That's why I screamed to Martin that I was waiting for his pull request, because the idea is that I start for a concrete need, and I generate the low-level binding. I publish it, I document, and then the rest of all the community can improve it. Otherwise, why not? And that's why also I release Pharo CIG in GPL license and not in MIT as is usual, because in fact it's something that you use and then you do not have a dependency, as you saw. So your generated project can be MIT or whatever license you want as a final consumer. But if you modify Pharo CIG to adapt it to your, I want that contribution. I want that for the community. So the generated code will give us a common floor. A Pharo design builds the house. That was it. So one thing, okay, the thing that is still missing is that I was not able to advance in C++. While easy C++ libraries are already being parsed, and for example I have libnoise, which is a C++ library parsed correctly, C++ tends to have a lot of problems and a lot of conference, and I just did it. It's doable, but I did not have the time, because the idea here is that you can generate a library, a library that makes the bridge between a C library that makes the bridge between you and C++, because there is no common IB, and it's kind of working, but it needs work to be reusable in complex C++ libraries. Before anyone asks for this, why an LLM can do that? Okay, I made a lot of tests to try to say, okay, because after all, an LLM is the place where it should shine here in this thing that is apparently just a translation. Okay, it's completely incapable of doing what I'm doing with Pharo CIG because it's not deterministic. So I will give you always a different result, which is not repeatable, of course. But if I tell an LLM, okay, read Pharo CIG, the repository that is public, read the projects that are public there, learn how to do it, and give me a recipe for this library, it's actually very capable of doing it. And then you have a recipe that is repeatable, that is deterministic, and that, which is also part of what I think that LLMs can be used as a friend of mine always says, it's an exoskeleton and not an AI worker for you that will do things. It's something that empowers what you are, can be used to empower something, but you have to be in control yet. So the promise is not that everything is automatic. The problem is that you will have a repeatable process later, a deterministic process that you can use to improve, to regenerate libraries when library change or whatever. one thing I'm thinking seriously, for example, is to move lib git from from what we have now to that, because we always have problems with that. We can just regenerate, but for that we need also modules. So better not. Okay, so the next bottleneck is not calling C because that's already solved. Is making native access shared infrastructure for everybody, for all the community. So we have the compatibility, C gives us repeatability, the garden is meant to be an ecosystem. Let's build the other side all together and come here.
Thank you, Esteban.